Hi, this is Jonathan Gardner. Today we're covering, or this video we're covering 1.6 significant figures in Survey and Jewett's Physics for Scientists and Engineers. And this is another important section. This is something that we do all the time in physics, and it's like breathing. Like when we multiply numbers, we keep track of significant figures. And what significant figures does for us is that gives us a really excellent measurement of the error of what we're calculating, right? Everything we measure has some error. And then we combine those measurements together. We multiply, divide, add, subtract them, and then that changes how the error of the answer changes, right? And so we keep track of significant figures to get a very good indication of what the error is of the final measurement, right? Suppose we're asked to measure the radius of a CD using a meter stick, right? So a meter stick is a meter long. And it doesn't have very precise measurements. It doesn't have very precise tick marks. So we put the CD on the meter stick, and then we're not really able to see exactly how many millimeters wide it is, but we measure, let's say, 6.0 centimeters. 6 centimeters, is that right? Yeah. And it could be plus or minus 0.1 centimeters, right? And we did our best. We pulled out a magnifying glass, and we said, well, it seems to be about exactly equal to 6. Maybe it's 5.9. Maybe it's 6.1. But we're very sure that it's somewhere in between there, and it's probably closer to 6, right? And so when we write the number 6.0 centimeters, this is two significant figures. And what this means is 6 centimeters plus or minus 0.1 centimeters, right? And so this information here contains that error of plus or minus 0.1 centimeters, right? There's a bit of a problem when we write significant figures on paper. So you might see the number 0.03, or you might see the number 0.0075, right? And so the question is, how many significant figures is this? Well, the first rule with significant figures is we always don't count the leading zeros. So this is one significant figure. This is two significant figures. Okay. When the zeros come after other digits, there's a little bit of confusion. So if we have 1,500 grams, is this two significant figures or three or four significant figures? We cannot tell. It's ambiguous, right? It could be 4, could be 3, could be 2, right? So we always rewrite something like this in scientific notation. So if we wrote 1.5 times 10 to the 3 grams, right, we know this is two significant figures. But if we write 1.50 times 10 to the 3 grams, this is three significant figures, okay? So in a case like this where the trailing zeros, it's not really clear that they indicate significant figures. We always rewrite it so that we have the trailing zeros indicated in our significant figures. And that's the same thing we did for 6.0 centimeters. If we wrote 6 centimeters, this would mean 6 centimeters plus or minus 1 centimeter, right? If we just wrote it that way. But since we write it this way, we know it's 0.01, okay? So we always use a scientific notation. We always have a digit here that's not 0, and then the number of digits after the decimal place is the number of additional significant figures that we have, okay? If we have a number like 0.000230, in this case, this 0 is not ambiguous. It's completely unnecessary. So we know that that's indicating that there's three significant figures. But again, we would prefer to write that as 2.30 times 10 to the minus 4, right? That's how we would write that, just to be explicit about significant figures. So if you turn in your homework and it has this as an answer, they might mark it wrong, but it's technically correct. But we really want you to get used to writing things in this way. Okay? Now, the question arises that what happens when we add, subtract, multiply, and divide numbers? How do we track the significant figures? Which ones do we keep? Which ones do we drop? And so the rule is for multiplication and division is you keep the lowest number of significant figures. Okay? So he gives an example where he says, so we know the area of that compact disk we measured is pi r squared So pi times 6.0 centimeters. So this is two significant figures, and we're going to square that. Okay. So 6 times 6 is 36 centimeters squared. I'm not putting 0.0 because it's only two significant figures. We're not increasing the number of significant figures. Now pi, we can write out pi to 10,000 digits if we really wanted to, but we only need the first few digits of that. I think the calculator here has a pi for me, so let's go ahead and write that down. So 36 times, let me find where pi is. I'm not seeing, oh, there it is. I think you just press that. Pi equals 113.09733355. So we're only going to keep two significant figures. So the area is equal to 1.1 times 10 to the 2 centimeters squared. Okay. All right. Now, when adding and subtracting, it's a little bit more complicated. Okay. Okay. What you do is you basically move everything to the furthest left. Okay. And the way to think of this is like, let's say you're adding the numbers 23.2 plus 5.174. Okay. This one is plus or minus 0.01. This one is plus or minus 0.0001. Okay. Now, these digits past here, these digits don't matter because it's absorbed in the error of this bigger number, this one that has a greater number of significant figures. So when we add this together, we're going to get 23.2 plus 5.17. So that's going to be 28.37. So 28.4. That's going to be the answer. Okay. Now, one thing to note is particularly when you're like adding a large number and subtracting that large number from it, the number of significant figures will virtually disappear. So he gives an example here. Let me write that out. He says 1.0001. So this one has 5 significant figures plus 0.0003. Well, that's going to be 1.0004. So this is the least precise digit. We're going to keep that digit there. Okay, but if we had 1.002 minus 0.9998, right? That's going to be 0.000, what is it, 4? I think that's correct. Yeah. So this number has 5 significant figures up here, but this number only has 1 significant figure. Okay, why did that happen? Well, it happened because the error, remember, is plus or minus point whatever 0.0001, and the error here is plus or minus 0.0001, and the error stays the same. So if we were to write 5 significant figures here, it'd only be significant when these leading zeros are all ignored, right? So the number becomes less precise. There's an issue that arises with rounding. Okay, so if the digit that you're dropping is bigger than 5, you're going to round up. If it's lower than 5, you're going to round down. But if it's equal to 5 and you always round up, you're going to accumulate more and more error and get further and further from the correct answer. And so what they recommend is you look at the previous digit. If it's even, you round down. If it's even, you round down, so you keep the even number. If it's odd, you round up, so you go to the nearest even number. Okay. Specifically, 1.25 becomes 1.2 when you drop the 5. 1.35 becomes 1.4. Okay, so we're trying to keep this last digit even. So we round up or down to keep that last digit even. Okay. And they have an example here, installing a carpet. Carpet to be installed in a rectangular room whose length is measured to be 120. Let me give you a new piece of paper for this. So we have a carpet whose length is 112.71 meters, and the width is 3.46 meters, right? So there's 3 significant figures here, and there's 4 significant figures there. And so what is the area? Okay, so we pull out our handy-dandy calculator, and we say 12.71 times 3.46, and so we get 43.9766. Now, how many significant figures? Well, we keep the lowest number of significant figures. So we're only going to keep 3 significant figures. So we're going to keep 43 point, and this last digit is a 9, but the next digit is a 7. So we have to round up. So it's actually 44.0 meters squared. Okay, that's the correct answer. If you wrote 43.9 meters squared, that's wrong. Okay, you're diverging too far from where the error points you. You're supposed to round that 7 up. Does that make sense? Hope you guys had a great day. Take care. Bye-bye.